Welcome to our very first episode. This podcast is brought to you by Beemet, a trusted name in electrical protection solutions. In this episode, we'll talk about digital earth leakage relays, why they are critical for modern electrical systems, common problems they face, and how to diagnose and prevent serious electrical hazards. If you've ever faced unexpected tripping, missed leakage faults, or unstable relay readings, this episode is for you. So let's get started. Modern electrical systems can cause safety and equipment hazards in case of earth leakage. Such dangers are usually prevented using Digital Earth Leakage Relays, ELR. The moment it detects an abnormal current, it cuts power and prevents hazards. Even the best systems can face challenges. For example, a relay may react to electrical transients and trip unnecessarily, or worse, it might miss a genuine leak and fail to act. That's why it's important to carefully evaluate these scenarios and plan solutions. Understanding Digital Earth Leakage Relay components. An ELR is a device that checks the flow of electricity through a sense core, CBCT, to make sure it is balanced. It sends a signal to the breaker to trip when the balance is lost. This prevents digital ELR faults from harming equipment or people. A basic system includes a microprocessor that analyzes current, a display that shows readings and relay status, a CBCT sensor that detects leakage, relay outputs and test functions that trigger tripping. If something goes wrong, you must check each component separately. Issues may arise from overloaded CTs, the algorithm responding to noise instead of leakage, faulty wiring, or tight terminals. It is therefore important to check fault assumptions before using them. Common digital ELR problems and diagnostic steps. Some common digital ELR problems with their diagnostic steps are false tripping. This occurs when the relay is tripping without a real ground fault. Harmonics, surges, or poor CT wiring usually cause it to cut power without saving the system. What to check? Check loads that may create harmonics. Tighten and secure CT wiring. Match trip settings with system values. No trip at actual leakage. Here, a real ground fault exists, but the ELR does not respond. This can lead to insulation breakdown, equipment damage, or shocks. What to check? Use a relay testing tool such as ELR injection tester to simulate rated leakage and observe response time. Check the CBCT output voltage for saturation or damage. Unstable or floating readings. This happens when the reading on the screen keeps going up and down for no reason. It generally means that there is noise interference or bad grounding. What to check? Tighten CT secondary wires. Reset the zero reading on the relay. Use a meter to check the backup power source. Communication or display failure. Such failures include blank screens and broken buttons. There will no longer be any monitoring available. What to check? Restart the relay fully. Confirm supply stays within 110 to 240 V. Test RS 485 and keys with a loopback. Systematic relay testing procedures. When subjected to rigorous testing, vague assertions like "it trips" sometimes transform into data that can be measured. Before you begin, ensure the relay is safely isolated before testing and make note of the settings. You can test how fast the relay trips by passing a small amount of leaking current through it. Press the test button and see whether there's any heat or dangling wires on the screen. Advanced diagnostic techniques for digital ELR faults. Looking more closely can be quite useful when problems aren't obvious. Checking earth resistance and waves for electricity noise is an advanced diagnostic skill for relay faults. Keeping log files can help solve difficult problems. Early warnings are also crucial to power system protection. That alerts you of a system shutdown. Preventive maintenance for panel protection systems. Good maintenance will keep relays effective for a long time. It is advisable to run the checks once in a month. You can run injection testing every several months and press the test button monthly. Whenever feasible, you can also update firmware and clean cables. Surge protection and early warning lights prevent surprises. This panel protection system keeps people safe. When to replace versus repair digital ELRs. Small concerns like wire cuts or calibration errors can be fixed with repairs. Bigger issues like broken processors or weak CTs require newer parts. Even the age of the relay also matters. When safety is in jeopardy, replacement helps reestablish trust. This will aid in electrical equipment maintenance over time. Conclusion: earth leakage demands instant response, and your ELR must act without hesitation. If it trips unexpectedly, fails during a fault, or shows irregular readings, it's time to test and recalibrate. At Beemet, our ELRs are engineered for reliability, protecting panels without uncertainty. Upgrade now to prevent small warnings from escalating into costly shutdowns or dangerous shocks. Thank you for listening to this episode. If you found this discussion helpful, don't forget to like, share, and subscribe to our channel for more insights on electrical safety and panel protection. To learn more about reliable digital earth leakage relays and protection solutions, visit our website at www.beemet.com. This podcast was brought to you by Beemet, engineering safety you can trust. We'll see you in another episode. Until then, stay safe.